Welcome to the HDIN Research 2026 deep dive into the brain-computer interface industry. Today, we examine the critical intersections of policy, competition, and the emerging synergies between human cognition and artificial intelligence. As we stand at the threshold of the brain economy, this report provides an objective analysis of the global landscape. The situation: we are witnessing a historic inflection point. BCI technology is rapidly transitioning from a laboratory curiosity to a validated clinical and commercial reality. The foundational science is settled. The focus has now shifted to scalability and market integration. Looking at the fundamentals, the global market is projected to reach approximately $8.5 billion by 2030. Long-term forecasts suggest the market could expand to $40 billion by 2035. While non-invasive systems currently hold the largest market share due to ease of adoption, the high-growth sector lies in invasive clinical applications targeting neurodegenerative diseases. The complication: despite financial optimism, the industry faces significant hurdles. Technical barriers in long-term biocompatibility and data bandwidth are complicated by a fragmented regulatory environment and rising geopolitical competition for standard setting. Our policy matrix reveals distinct regional philosophies. The U.S. continues to lead in neural tool development through the Brain Initiative, while China focuses on building a comprehensive industrial ecology. The EU remains the gold standard for data privacy and ethical frameworks, while Japan and Korea lead in robotics integration. In the United States, leadership is maintained through an efficient pipeline between research universities and private enterprise. The FDA's breakthrough device designation has been instrumental in shortening the time to market for pioneering firms like Neuralink and Synchron. China's advantage is largely asymmetric. By identifying BCI as a frontier industry in the 14th Five-Year Plan, the state has streamlined clinical resources. With a vast patient pool and significantly lower costs for human trials, China is rapidly closing the gap in material science, particularly in flexible electrodes. The central challenge for stakeholders today is commercial viability. How can companies balance the trade-offs between high-bandwidth invasiveness and the biological stability required for long-term implantation? The competitive landscape is diversifying. Neuralink represents the high-bandwidth, high-risk approach. Synchron is leading the minimally invasive endovascular path, and Paradromics is positioning itself as the data infrastructure leader for neural signals. Synchron offers a compelling case study for clinical adoption. By utilizing the vascular system rather than open brain surgery, they have significantly lowered the surgical barrier, recently achieving milestones in integrating neural control with consumer electronics like the Apple Vision Pro. Neuralink remains the standard bearer for bandwidth. Their N1 system, featuring over 1,000 recording sites via ultrafine threads, aims not just for medical restoration, but for a future of human-AI symbiosis. Their progress in wireless power and robotic implantation is industry-leading. Domestically in China, companies like NeuroXS and StairMed are emerging as formidable players. We see a strong trend towards specialized applications, such as NeuroXS's use of silk protein materials and Neuracle's focus on stroke rehabilitation. The answer: we believe the ultimate solution to the BCI communication bottleneck lies in AI. By moving from simple decoding to generative AI models, we can translate fragmented neural signals into coherent language or action with unprecedented speed. The synergy between LLMs and BCI is transformative. Predictive algorithms allow for faster communication, neurosemantic models reduce the need for user-specific calibration, and emerging AI thinking passwords offer a new layer of cognitive privacy. The market is expanding beyond clinical use. We are seeing the first steps toward social re-employment for the disabled and the potential for BCI to serve as the next-generation input method for extended reality and education. A reality check is necessary. For BCI to achieve mainstream medical status, it must provide 5 to 10 years of biological stability, bridge the psychological gap in patient trust, and, crucially, secure sustainable reimbursement pathways from health insurers. Investment remains strong, with over $10 billion in cumulative financing. We note a significant shift in capital toward downstream clinical applications and a preference for invasive technologies that offer high-moat long-term therapeutic value. Looking ahead to 2030, we anticipate the brain economy. BCI will serve as the core interface for the digital self. This isn't just about medical recovery. It's about redefining the very limits of human productivity and intelligence. Thank you for your attention. At HDIN Research, We specialize in providing the data and clarity needed to navigate these frontier markets. If you require a deeper market study or customized analysis, please contact us at sales@hdinresearch.com. We now open the floor for questions.